So welcome to another lecture. In this lecture again we'll be solving a JEE Mains question. This was asked in year 2026. I found this very interesting because there are three concepts that you can understand when you are doing this question. Uh, the question is there. You can try to read the question, try to do it on your own, uh, try to figure out your own way how you can do it before you start looking at the solution. One hint that I can give to you is that these would be the list of formulas that would be used. So you can have a look at these. Whatever I am discussing, the formulas, the solutions, etc. They will be there in the PDF notes in the comment section in the description. So you can download it from there. So these are the formulas that we will be using: quadratic equation, log differentiation types, integrals, first order differential equation, exponential properties, differentiation, product rule, chain rule, uh, sign analysis, interval concept. So, these are the list of topics that would be used when you are solving this question. So, try to solve this question on your own. Uh, I'll start with the solution now, and I won't be, explaining these formulas now. But in the end of the solution, I'll be, spending some time to explain you the formulas. Let's start. We'll understand the question first, and then we'll look at the solution. So, let's start. So, let's read the question first. There's a function which is twice differentiable function such that the quadratic equation, this is a quadratic equation in M, has equal roots for every x belongs to R. So in a way, this is the first condition which is given to us, that there is a quadratic equation which involves the function and its differential, and there is some constant M in the quadratic equation. So this is the first input that we have. If f of 0 is 1, f dash 0 is 2, so this is the second input that we have, that for the function f of 0 is 1 and f dash 0 is 2. This is the second input that we are given. Third, alpha beta is the largest interval in which this function is increasing. So this function is increasing in the interval alpha beta. This is the third input that is given to us. Then alpha plus beta is equal to, this is what we need to calculate. So this is what we need to calculate. Now, when you are reading this question, at least when I am reading this question, what I don't understand is, what is fx? So I don't know what is fx. And I presume, before I start the question, that when I will be using these inputs, input 1 and input 2, they will be leading me somehow to fx. So this is how I start. Now I'll show you the solution. There will be various steps. So slowly, the first step that we'll be taking is, we'll try to find what is fx. Then once we have the fx, we'll use this and see in which interval is this increasing. And once we have that interval, basically we'll have alpha and beta. We'll just then add, and then we'll have the solution. So this is the broad path that we'll be taking. And as I've told you, these are the formulas that I'll be using. But when I'm explaining you the solution, I won't be explaining these formulas. Formulas I'll explain at the end. So this is how the solution looks like. So this is the first condition that I have taken. The first condition that I have taken is that I've been told that this condition has been given to me. This is the first condition which is given to me, and I've been told that this has equal roots. Now this has equal roots, fine. So discriminant would be equal to 0. That is a given that we learn in class 9, class 10. So that is given. So this is a quadratic equation in M. So b square, this is my b, this would be my b square minus 4a and c. So I'll have to calculate the discriminant. So 4 f dash x square minus 4 fx f double dash x is equal to 0. So this is my this is my b square, and this is my a c. I'll again show you the a. This is my a fx, and this is my c f double dash x, and this is my b minus 2 f dash x. This whole of this is my b. I hope it is clear. Now when I use that and I equate it to 0, this is where I reach that f dash x whole square is equal to fx into f dash double dash x. Okay, this is my step one. At step one, this is where I have arrived. Now I understand that this has taken a shape of a differential equation, and I have to find the value of fx. So I rearrange the terms like this, that f dash x upon fx is equal to f double dash x upon f dash x. I take integral on both sides, and then I realize that why am I doing this? Because I realize that this for this I can use this formula. For this I can use this formula, that integral of f dash x upon fx is equal to log fx plus c. Similarly, I can use for the other term I can use this formula, that integral of f double dash x upon f dash x is equal to log of f dash x plus c. So these are the two formulas that I am using at this step. So that is why this f dash x upon fx would be equal to log fx, and f double dash x upon f dash x would be equal to log f dash x plus log c. Again, I rearrange this and I write this as f dash x is equal to k fx. So I do some manipulation, so I can write this. I can write this line as log f dash x is equal to log fx plus log c. I can rearrange, because see, the sign of the constant doesn't matter. It doesn't simply matter. So you can write it like this also. So this log f dash x is equal to log fx plus log c. This becomes f dash x is equal to k fx. I've taken anti-log on both sides and the log has vanished. Now this is my end of step 2 and the beginning of step 3. Again, this is a differential equation whose solution is f of x is equal to a e raised to power kx. So this is a standard form whose solution looks like this. Now I have two constants. One constant is a, the other constant is k. Now I have to find the value of a and k. How do I find the value of a and k? For that, I go back to the question again and I realize that the second input that I had was that f of 0 is equal to 1 and f dash 0 is equal to 2. Now I'll be using these two inputs. F of 0 is equal to 1. F of 0 is equal to 1. So when I put f of 0 is equal to 1, so it is equal to a. So a e raised to power k0, this would be equal to e raised to power 0 is equal to 1, and that is why this becomes a is equal to 1. So I have the first input, which is a is equal to 1. The value of first constant a is equal to 1. And now I have to find the value of k. Now fx is equal to ekx, a is equal to 1, so that vanishes. Now I have to find the value of k. What I do is I take a differential. Why do I take a differential? Because I have the value of f dash 0. So f dash 2, I have the value of f dash 0 is equal to 2. This is what I am given. So that is why I take a differential. So f dash x is equal to k e raised to power kx. So this is the differential of e raised to power kx. And now because I have the value, so I find the value of k is equal to 2, and finally I reach at end of step 3. I reach this function. That function, the given fx is equal to e raised to power 2x. So this is the first time I have seen the function. So in the question, whatever they are talking about fx, now it's the first time that I have concluded that this is how my fx looks like. And now, once I have seen fx, so I know what does f of log to the base e x minus x looks like. And log to the base e is written as ln x, and that is what I have used here. So that is why you see here that f of log x minus x is equal to a raised to power 2. So whatever be the x, you have to put the value of ln x minus x here. So this is what f of ln x minus x looks like. See, why do I need to calculate this? I need to calculate this value of f of ln x minus x because the third input basically the third input in the question is, yeah, this is the third input. The third input in the question is the function ln fx minus x is increasing. So I need to see what f ln x minus x looks like. Only then I'll be able to find the interval in which it is increasing. So that is why I'm taking this route. Now e raised to 2 ln x minus x, so 2 ln x minus 2x. Now here again you'll have to be a bit cautious to use this. See, one thing that you need to understand is that this 2 ln x can be written as ln x square minus 2x. Now this can be further broken up. This whole can be further broken up as e. Let me write it here so that you can see clearly. This can be written as e ln x square minus multiplied by e raised to power minus 2x. Now this term, because here also the base is e, this would be simply be equal to x square multiplied by e raised to power minus 2x. I hope this is clear. So this function x square into e raised to power minus 2x, this is the function. Now primarily this is the function which is increasing in the interval alpha beta. Now I'll be focusing on this function. I'll be taking a differential of this function and I'll be calculating the the interval in which it is increasing, so that I can finally conclude what is alpha and beta. So I name this as gx. I take a differential of gx. So this is what the differential of gx looks like. So when I do the manipulation, g dash x is equal to 2x1 minus x e raised to minus 2x. So what you need to realize is that this function e raised to 2x would always be positive. For all x, this is positive. So the sign of the function, the sign of the g dash x depends on this variable x into 1 minus x. So the sign depends upon x into 1 minus x. The 2 points that are of interest to us are x is equal to 0, x is equal to 1. Now in this interval, this is always negative. In this interval, it is positive, and in this interval, this is negative. So, calculating the signs, that is the understanding that you should have. I can't go into explaining this now. So this is the understanding that you need. So, finally, I realized that this is an interval in which this is positive. Therefore, g dash x is positive, and therefore my f of ln x minus x is increasing. I hope this is making sense. So this interval is basically 0, 1. So my alpha would be 0 and my beta would be 1. And alpha plus beta therefore would be equal to 1. So I found this pretty interesting, but the only thing is that you should have a thorough knowledge of all the topics, and this is a JEE Mains question. So very quickly you should be able to go through all the steps without any mistake. So finally I'll take you through the formulas that I've used during this solution. So first is the equal roots condition. I hope this is more or less clear for everyone. B square minus 4ac is equal to 0. Then I used logarithmic differentiation, a basic log differentiation, that d of dx of ln fx is equal to f dash x upon fx. We should have an understanding of this. Then this is the integral formula that I used. We discussed this during the solution also. And this is the first order differential equation. This is what I used, and I told you that you can have a look at your textbook and you'll realize this is the solution of this differential equation. And whenever you see a equation like this, you have to find the value of a and k, and a and k basically are found using the conditions which are given in a question initially. Then we used these exponential properties, EA into EB. This is very critical to understand. This is usually taught in the logarithmic function chapter. This is what we used. We discussed this also because this can be written as E ln x square and there is a E here, and this E here, basically crude way of looking at this is that this E and this E will cancel and this would be equal to x square, and that is written here. Then we use the, for finding the differentiation, we use this formula also. We use the chain formula here. So d by dx of E gx is g dash x E gx. Important formula that you should understand. And then we use the increasing function, uh, first differential test, easy. Then we use the sign analysis also, and then the integral concept. So I found this question pretty interesting. I wanted to discuss this question because there are a lot of interweaving concepts that are used in this topic, and I hope you found this useful. I'm doing this series of lectures where I'm doing JEE maths and physics questions. Please subscribe to the channel. Please like the if you have like the lecture. If you have any queries, please comment below. I'll be happy to uh, reply to you whenever you are watching this video. I'll be glad to reply to your question, and best of luck, and see you in the next lecture.